Now that we've seen how to create simple event emitters, let's look at a class that uses event emitter. So um, event emitters are great for doing things asynchronously. So in a regular JavaScript program, you might call a function, and then the function does something or it waits for something to be finished, and then it returns a value when it's done. And that kind of model is really good for putting together sequences of actions where you have to do each step one at a time in order until you get to the end and then you're done. But a lot of things in the real world happen asynchronously. So they don't happen in any particular sequence, and there may be a significant amount of time between when one thing happens and when the next thing happens. And if you were just sitting there waiting for the next thing to happen, you might end up waiting an awfully long time, and meanwhile you'd be tying up the whole computer. So that's not good. So what we want to do instead is use an event emitter model to deal with the events as they arrive. And an example of that is asynchronous communication between two processes. So for example, I might have a server running on one machine or even on the same machine, and I want to connect a client to that server, and then the client can send data to the server and the server can send data back to the client. And all of that might happen asynchronously. So the server might send a couple of messages to the client, and then the client sends a message to the server, and then the server might respond to that message, and then I might wait some more time, and then another message might come from the server, and so on. There's really no predicting what order things will happen or how long the wait will be between each time. So what we're going to do instead is every time the server sends a message to the client, that's going to cause an event to happen. And the client will listen for that event. And when it hears the event, hey, the server has sent data, the client will go ahead and will process the data that arrives, and then the listener will be done with handling that particular request. And so the client can go on and do whatever else it needs to do in the meantime. So basically, the client is set up to respond to events that are initiated by the server, and similarly, the server can be set up to respond to events that are initiated by the client. So in this kind of communication model, whenever the client wants to send a message to the server, it generates an event that the server responds to, and whenever the server wants to communicate with the client, it generates an event that the client responds to. So that's what we have going on here in the net package. So this is one of the packages that, once again, I think this is bundled with a Node and Node Package Manager out of the box when you install Node. And if it's not, you can npm install net to get it. But what the net package does is it allows you to create servers, and it allows you to create sockets. So a socket is a communication endpoint. So basically, you take two sockets and you connect them together, and that becomes a channel that you can use to send data from one socket to the other socket. So typically, you'll have a server that is listening for a connection, and then a client which creates a socket and tries to connect it to the server. And when the server hears that the client is trying to connect, it creates a socket to connect to, and then the server and the client can exchange data across the sockets. So let's look at what the net package offers. And there's a lot of detail in here and a lot of things that are less commonly used, but actually getting started is pretty easy. The main classes are, there's a server class in the package, and the server is an event emitter. So various events can happen that the server will notify the rest of the world on. So you can find out that the server is closed. You can find out that the server has gotten a connection from a client. You can find out that there was an error. And you can find out that the server has begun listening for connections. And we're going to use some but not all of these events. And then the other main class that we want to look at is socket, once again a communication endpoint. A socket is also an event emitter. So various things you can listen for. You can listen for the socket to be closed, which means that the communication channel is going to be closed. You can connect a socket to another socket to initiate the communication. You can send a data packet. There's this drain event, which has to do with whether a write buffer is empty or not. We're not going to use that. There's end when the socket is closing and going to go away. There's an error condition if there's a communication error on the socket, and so on. So lots of events are emitted, but we are only going to need some of them for our program. And then each of these classes also has methods. So for the server class, you can make a new server object. And there's also a helper function called create server that basically does the same thing. You can listen for connections. So I'm going to wait for a connection from a client and respond to that. And then you can get the things that are connected and some other stuff. But mostly you can close the server when you're done serving. So, and then socket class, the main things you want to be able to do are read from the socket and write to the socket. So here's a write command. It takes a data packet and a callback, and the data gets sent to the matching socket, the socket it's connected to. And then when the data is sent successfully, you can execute a callback function, which is optional. So actually, there is not a read here. You'll notice there's no socket.read, but the reason is because we're using event emitters instead. And so instead of doing a read on the socket and sitting there and waiting, what you're going to do instead is listen for a data event. So let's just see a simple example of this. So I'm going to go to my test folder, and I'm going to create 2 new JavaScript files. And the first one's going to be server.js. And the second one is going to be client.js. Okay, so both of these are going to say const net equal require net, and put that in server as well. And then I'm not going to write a class with this yet, so what I'll just so I'll just go ahead and call stuff directly. So the first thing I want to do is make a server. So const server is equal to net.create server. So now I have a new server object. And then I can set up some listeners. So the things that I care about are server.on. I got some data. And I'm going to get that as a parameter to my event handler. And then let's go ahead and check for errors. Whoops. And this is going to give me an error object. And let's just console.log error. And what else do we need? Let's get a connection. And the connection is going to give me a socket. So this is going to be the socket that I use to communicate with the client that just connected. And here I'm going to say console.log socket. And that should be it for this. I'm going to go ahead and put some white space in here and also end those lines. So now I have a server and I've set up some event listeners and some event handlers. And then the other thing I want to do is start listening. So that'll be server.listen. and you give it a port. So I'll just listen on port 1234. For HTTP servers, you usually listen on port 80. For HTTPS secure web servers, you usually listen on port 443. But you can pretty much listen on any port that's not already in use. And then there's a callback that gets called when the socket actually starts listening. And I'm not going to actually do anything with that. So I'll just go ahead and I could console.log listening for connections on port 1234. Should make a constant out of that, but not important for now. And that's really everything there is for the server right now. On the client, I'm going to make a new socket. New .socket. And then I connect the socket. And here I give it a port and a host name. So the port is going to be 1234, and the host name is the address on the internet where the server is running. This server is running on the same machine as this client, so I can just put localhost here. You could put an IP address as well for localhost. It would be 127.0.0.1. Or if I had the server running on a remote machine, I could either put the host name and domain name of the machine if it was publicly accessible on the net, or the IP address if there was no name service for it. So let's go ahead and run both things and see what we get. So I have a command shell open. I have this project parked in my WebStorm projects test folder. And I'm going to need two of these command shells, one for the server and one for the client. So cd WebStorm projects test. And let me go ahead and start the server. So it's listening for connections on port 1234. And then this guy over here is going to be the client. So the client created a socket and then connected it. And when the socket was connected, the connected event listener went off, and it console.logged the socket that it got past. So we've established our connection. Now you'll notice that this is just sitting here, and it's sitting here because it's listening for events to arrive. But we haven't really programmed any events. There is an event that we can cause though. Let's go ahead and Control C here. And when I Control C, you'll notice that it threw an error, an unhandled error event, actually on the socket. So we're listening for errors on the server, and those are going to happen when we try to start up the server. So let's see what happens if I do this. So I'm going to start the server here, and I'm also going to try to start the server here. So this one, I actually get an error, EADDR in use. So this was the on-error listener for the server. But what threw an error over here is the on-error listener for the socket. So if we want to fix that, that's going to be on the server side. And when I got this connection here, I can also, since socket is an emitter, event emitter as well, I can say socket.on error, and then this is going to give me an error object. And here I'm going to just console.log socket error, and then error has a code, which is just a piece of text that describes what type of error it is. So let's go ahead and try that again. So I'm going to kill my server and restart it. And then I'm going to go to my client. Oops. Start my client. I got the connection, so it showed the socket. And then I'm going to Control C, and I got my socket error econ reset. And it didn't crash because I didn't throw an error from there. So this is how I can detect that the communication link has been broken. And this will also happen when the client wants to shut down. Now, socket's an event emitter, and we're handling the on event, but let's go ahead and handle the data event as well. So that's going to be socket.data, oops, socket.onData. And then that's going to give us a data buffer. And we'll go ahead and log that buffer just to see what we're getting. And then on the client side, once we've gotten our connection, so socket.connect, here's the callback for the connection. And so what we should be able to do is socket.write hello world. So that should send a packet of data to the server, and then the server should get that packet and display something to the console. So kill the server, restart it, and then we'll run the client again. So it went ahead and it sent the data, and here's how it showed up on this side. So it's basically a byte buffer. Let's see, it's HELLO space WORLD exclamation point, and 20 is a space. So the communication is working. Now, the thing about socket communication is it's stream based, which means that you can send a stream of information. But what the networking infrastructure does, the driver and the networking hardware, is it takes a continuous stream of information and it carves it up into little chunks of data. And then each chunk of data gets wrapped up in a bigger data structure that has header information, and that's called a packet. So a packet, it has a buffer of data, and it also has header information that describes the size of the data and where the data is coming from, the IP address and port, and the protocol that's being used, and a bunch of other stuff that's internal to the implementation of TCP. So the thing about the way that it gets carved up into a stream is you can't necessarily predict exactly where it's going to get carved. So if you send it a long line of information, it could get carved into 3 or more, however many packets. And you'd have to reassemble those packets on the other side in order to recover the whole message. On the other hand, if it's a very small amount of data, it might not get sent right away. It might get queued up, and then when you get enough data, that data might be put together into a packet, and then the packet is sent across on the communication stream. So you can't necessarily control exactly when the data will be delivered or how many messages will be delivered at once. And so you have to handle that yourself as a programmer. And there's basically 2 approaches to dealing with it. The first approach is, before I send you the data, I'm going to tell you how much data to expect. And I know that's going to be like an integer, which is 4 bytes. So I send you 4 bytes, and then I start sending you the data. And that's however many bytes I say that I was going to send to you. So now you read the 4 bytes, you know how much data is coming, and you can keep reading until you get that much data. And that gives you the original chunk of data that was sent. And then anything left over, that's going to be another 4 bytes for another length, and then the start of another chunk of data. So you can basically carve out the original messages from the data stream because I've told you how long each one is. So that's one way of doing it. Another way of doing it, which is appropriate if you're dealing with text, is to do like line-oriented input and output. So if I make sure that every buffer of data that I send from the client to the server and from the server to the client is exactly one line of text, then I can just keep reading until I hit the end of line. And I can also carve out a block of data every time I see an end of line. And that's what I'm going to do here because I'm going to be using this to build basically a chat server and a chat client. And so I'm going to be sending a lot of text around. And I'll show you a cool trick with JavaScript object notation. So what I want to do is I want to take the socket, which is sending buffers of bytes, and instead I want to use it to send lines of text. And so what I'm going to do is basically take the socket event emitter here, and I'm going to wrap it with another event emitter called readline. So let me go ahead and import readline. And then readline lets you create an interface around a data stream. So a data stream that's an event emitter, you can wrap it up in a readline object, which is also an event emitter. And this is going to take the low-level data events, and it's going to bundle them up and emit line events. So to do that, what I do is I take the socket. Let me get rid of this on data because I'm going to handle all of my data through readline. So I'm going to make a socket line reader, and that's going to be rl.createInterface. And then you give it the input source for reading lines. And then optionally, you can also give it an output source for bidirectional communication. And since sockets are bidirectional, I'll just go ahead and use socket here too. I probably don't need to do it in both places. And then the socket line reader is now event emitter. So I can say socket line reader dot on line. That's going to give me a line of text. And let's console.log line. Okay, so let's go ahead and try that. So I'm going to run the server, and let's run the client. Oh, and it hasn't done anything. And the reason it hasn't done anything is it sent the data hello world, but I haven't ended the line. So let me go ahead and start this again. The server's fine, but in the client, I want to end this line by using a new line character. And you'll often see \r, which is a carriage return, followed by \n, which is a new line. I think just \n will work. At least it works on Windows. But you might need \r, \n on Mac or Linux. So this time, when I ran the client, let's go back to the server. You see I got the line hello world. So it read up to the line and then gave me a line event when it hit that much data. Now, I could also do this. Hello world \n, second line \n, and then the start, and then socket.write of another line \n. So here I'm sending 2 whole messages plus the start of a third message in one buffer, and then the end of a message in another buffer. But read line is going to put everything together into separate lines. So actually, let's go ahead and run node server, and then here I'll run client. And you'll see I got back 3 lines, which is convenient. Now, obviously, since this is a bidirectional communication link, I can do exactly the same thing on the client side as well. So I can say const rl is require read line. And then when I get my socket connection, I can go ahead and say socket line reader is rl.createInterface. Socket, and then socket line reader dot on line. I'm going to console.log line and then whatever was sent. So here in the server, when we get a line, I'm going to go ahead and display it to the log, and I'm also going to socket write the server acknowledges your line \n. And now on the client, every time after each line, I should also get a line event that's acknowledging each line here. Now these are going to be delivered asynchronously, so I might get 2 here and then a third one when I send this, or I might get all 3 of them one at a time at the same time. Can't really tell when the packets are going to get delivered, but you know they're going to get delivered in the right order. So here's the server, here's the client. So I got 3 acknowledgements because I sent 3 separate lines.